Hey guys, we are on Unit 2, Day 5, solving fractional equations continued. So we started these on Day 4. However, there's quite a bit of examples and practice that we need in order to not make mistakes so that our answers come out what they're supposed to come out to be. So in number 1, there's actually something that we haven't seen. We have a fraction plus a fraction equal to a number, and on Day 4, it usually was a fraction plus a fraction equals a fraction. Well, in number 1, our first step is to give this 4 a denominator, because don't forget, not just the first two have to be the same. All of them need to be the same in order for us to ignore the denominators and focus on solving the equation in the numerators. There is no way to turn an x into an x plus 1. A lot of people think that they could put a 1 next to it, but remember, you're not adding 1, you're multiplying by 1, and 1 times x is not x plus 1. It's 1x, and so that doesn't work. So the only way that we can make all these denominators the same, we're going to make our LCD, our lowest common denominator, not only the x, but also the x plus 1. Okay, so this first fraction is going to need the x plus 1. Don't forget, the rules of a fraction are whatever you do to the bottom, you must do the same thing to the top, because x plus 1 over x plus 1 is really just 1, and multiplying anything by 1 is just fine. Okay, the next fraction is going to need the x. So both of those fractions have the x and the x plus 1. Therefore, this last fraction is also going to need the x and the x plus 1. And if you want to make it easier on yourself, it's fine leaving them apart on the bottom, but because you're going to have to multiply 3 things together, the 4, the x, and the x plus 1 on the top, you might want to go ahead and put these back together here and say that x and x plus 1 is actually going to make x squared plus x if you think about distributing. So it might be easier to go ahead and put that on the top, x squared plus x, because that really is x and x plus 1. It's just put together instead of factored. Okay, so if you remember, you are to check that, make sure all denominators have the same stuff. So this is x and x plus 1, this is x and x plus 1, and this is x and x plus 1. And we gave the same expression to the top as we did to the bottom. And so that is how we can just focus on solving the equation in the numerators. Okay, so in this first one, we're going to go ahead and distribute. That's a 7x. And that's a 7 times 1, which is 7. You had a plus sign next, so we don't have to be too careful. And then we have a 4x times x, which is a positive 4x squared, equal to, and this is why I put those two together, so that all we have to do is distribute here and get 4x squared plus 4x. Okay. All right, so now our job is to go ahead and say, all right, we have square terms. So chances are we're going to have to factor, but we cannot factor unless we're equal to 0. And so we're going to go ahead and move some stuff around so that we can get equal to 0. But if you think about it, if you subtract this 4x squared term, or you subtract the other 4x squared term, what's going to happen to the 4x squared terms is that they're going to go away and they're going to go away. It's a little strange, but that happens. So the only thing we have left is a 7x plus 7 on this side equal to a 4x on this side. I guess I'm going to go ahead and subtract the 7x. And I am left with a 7 equal to a negative 3x. To get x by itself, we're going to have to divide by negative 3. And x comes out to equal negative 7/3. Not the greatest answer in the book, but it's an answer. And now what we have to do, we can't just accept all of those answers or any of these answers, especially if they make our fractions in the original problem undefined. And remember, an undefined is a 0 in the denominator. So I'm going to clear this off so I can see my denominators. And now I have to take my answer of negative 7/3 and see if I put a negative 7/3 here, is that going to turn that fraction undefined? No, because turn the denominator 0. It'll turn it into negative 7/3, which is fine. And if I put negative 7/3 in for this x plus 1, that's not 0 either. And this last fraction can't be undefined. And so we're going to go ahead and say that our answer of negative 7/3 will stay. Okay. All right, let's take a look at the next one. All right, so in number 2, the very first thing I recognize is that this denominator here is a trinomial, and we've seen one of these on day 4, but when we pull it apart, chances are it's going to be made up of the other 2 denominators. So we'll see if that still works. Okay. All right, so we're going to go ahead and set up our X box. Our multiply is going to be negative 12, and our add is going to be negative 1. And if we think about the numbers, they're going to have to be a 3 and a 4. And to get a negative 1 out of 3 and 4, we're going to make the 4, the bigger number, negative. So that works in the multiply and it works in the add. And then we're going to go right underneath this trinomial and we're going to say he's easy. So we're going to split him up into his factors of x minus 4 and x plus 3. All right. And I'm just going to get rid of that because it's been replaced with its factored form or its equivalent form. So what I'm seeing is that the first fraction has the x plus 3, but it's going to need the x minus 4. And remember, whatever you give to the bottom, you're going to have to give the same thing to the top. Okay. This fraction has 4 minus x. Is that the same thing as x minus 4? Compare your x's. Are they the same? They're opposites. Compare the 4's. They're also opposites. So what we're going to need to do is we're going to need to put a negative 1 here. Okay. And I'm going to show you what happens. But again, if you put a negative 1 on the bottom, you're going to have to put a negative 1 on the top. Okay. All right. So I'm going to go ahead and figure out what this equals. A negative x times negative 1 is going to turn that into a positive x. And the 4 times the negative 1 is going to turn that into a negative 4. Do you see that? And so now I'm going to get rid of this because it's been replaced with its equivalent form. And now what does this middle fraction need? He needs the x plus 3 still. He has the x minus 4, but he needs the x plus 3. And he didn't have the x minus 4 before. He had the 4 minus x, but by multiplying the top and bottom by negative 1, it changed its bottom into x minus 4. Okay, so I put the x plus 3 that it needed on the bottom, but again, it's going to need an x plus 3 on the top. I'm going to have to be very careful up there. Okay, all right, so again, x plus 3 and x minus 4, x plus 3 and x minus 4, x plus 3 and x minus 4. And so by doing that, that allows us to say, all right, the denominators are all equal, therefore the numerators must be equal. And now we can go ahead and take and see what's up there and solve it. Okay, in the first fraction, that's not terrible. It's 2 times x, which is 2x. 2 times negative 4 is negative 8. What we're going to have to do is we're going to have to be very careful with this minus sign. I'm going to change it to a plus sign, and I'm going to put that negative just a little bit closer to the negative 3. And I'm going to take care of this right here. Negative 3 times negative 1 is 3. And now all I have to do is distribute that 3 to what else I put up there, which is a positive 3x. And 3 times 3 is positive 9. You got the equal sign next. And we gave that fraction nothing because it didn't need anything. It already had everything it needed. Okay. All right. So what's nice about this is that there is no square term, so you don't have to factor. So we're just going to go ahead and combine our like terms on the left side, which gives us 5x. Negative 8 plus 9 is positive 1, equal to a 2x minus 2 on the other side. I'm going to go ahead and subtract 2x. And we're left with 3x plus 1 equals negative 2. I'm going to go ahead and subtract the 1. And we get a 3x equal to negative 3. We're going to divide by 3. And x comes out to equal negative 1. And again, we can't just accept the answers we get at the bottom. We have to go back and take a look at our denominators and see if our answer turns any of them into 0. Because if it does, we have to say goodbye to those answers. All right. If I go and I put a negative 1 in for x, negative 1 plus 3 is not 0. It's 2. So that's fine there. If I put a negative 1 in for that x, that's actually 4 minus a negative 1, which is the same thing as saying 4 plus 1, which is 5. And so it's fine there. If I put a negative 1 in for this trinomial, that's a negative 1 all squared, which is positive 1, minus a negative 1, which is actually plus 1, and then minus 12. Well, that's not 0 either. And so this answer here is fine. He can stay. He makes none of my fractions have a denominator of 0, so he makes none of my fractions undefined. And those answers can stay then. Okay. All right, let's take a look at number 3. Oh, this isn't bad at all. Hopefully you guys can tell that the LCD is going to be 3x. And so the first fraction needs a 3, top and bottom. Second fraction needs an x, top and bottom. Last fraction already has the 3x, and so that's 3x, that's 3x, and that's 3x. So now we're going to just focus on what we have in the numerators. 3 times 1 is 3. Be very careful with that minus sign. This one shouldn't trick you up too much, but you can still go ahead and get in the habit of putting a plus, making it a plus sign and putting the negative closer to the number in the numerator there. And so negative 1 times x is negative x equal to, and that negative, when that negative is out in the front of that fraction bar like that, you can either take it with the top or with the bottom. And we didn't take it with the bottom because that's a positive 3x in the bottom. And so we're going to make sure that we take it with the numerator then. And so that'll equal a negative 1. Well, that's a really easy equation to solve. We have no square term, and there's barely any terms in here. So I'm going to go ahead and subtract the 3. What I have left is a negative x equal to a negative 4. I'm going to go ahead and divide by negative 1, and x will come out to equal positive 4. And again, we can't just accept the answers that we get. We have to make sure that none of our answers, that's not what I wanted to do, none of our answers make those denominators turn into 0. There we are. All right, so now that I can see my denominators again, we put a 4 in for that x. Oh, there we go again. I don't know what happened there. Must have changed my pen. Okay. If we go ahead and put that 4 in for x, that fraction is going to be fine. Okay. And if we put the 4 in for this x, 3 times 4 would be 12. And so that fraction is also going to be fine. None of our fractions will have a denominator of 0. Therefore, our answer of x equals 4 can stay. Okay. All right. Let's go ahead and take a look at our next one. Okay, so I see p minus 5s and p plus 3s. And there is no way to turn a p minus 5 into a p plus 3, so I think our LCD is going to have to be p plus 5 plus 3 and p minus 5. So our LCD will be both p minus 5 and p plus 3. Okay, so this one's going to need the p plus 3. Top and bottom. This one's going to need the p minus 5, top and bottom. And this one's going to need the p minus 5, top and bottom. And so I believe now all of them have p plus 3, p minus 5, p plus 3, p minus 5, p plus 3, p minus 5. And so we can go ahead and just focus on the equation that we get in the numerators. Okay, so we'll take it down here. 3p times p is 3p squared. 3p times 3 is positive 9p. All right, there's that minus sign. Turn it into a positive and put it closer to the 2. And now we're distributing a negative 2. So negative 2p and positive 10. Equal sign. P times p is p squared. And p times negative 5 is negative 5p. All right, so this one's a little bit tougher than the last couple that we've had there. I think I'm going to go ahead and clean up not only this side, but I think because I'm still going to have a p squared term, that means I'm going to have two answers. I won't get them unless I factor, and I can't factor unless I'm equal to 0. So I'm going to go ahead and subtract p squared, put it right underneath the p squared term. Those will be gone. I'm going to go ahead and add 5p. I'm going to put it underneath here. Those are like terms, and that'll be gone. Okay. 3p squared minus p squared is 2p squared. I have a 9p minus 2p, which is 7p, and 7p plus 5p is plus 12p, and then the plus 10. And we are equal to 0. So now we're in good shape to factor. So we ask ourselves, what kind of factoring do we want to use? And hopefully you always check greatest common factor. And there is a 2 in common, so we're going to pull it out. We'll be left with p squared plus 6p plus 5 equals 0. And by doing that, pulling that 2 out, now I have just an easy trinomial here. So we'll throw up our x box. Our multiply will be 5, and our add will be 6. And the only numbers that multiply to 5 are 5 and 1. And good news, 5 plus 1 is 6, and 5 times 1 is 5. And so we're going to leave them both positive. And because it is an easy trinomial, we can go ahead and bring the 2 down. We'll split the easy trinomial into its two factors of p plus 5 and p plus 1 equal to 0. All right, we do have 3 factors. However, this factor of 2 in the beginning has no value of p in it, right? There's no p in it. So if I set 2 equal to 0, there is no p to solve, and this just goes away. Okay? But here I would get p equal to a negative 5. And on the end, I would get p equal to a negative 1. And so I have 2 answers. However, we got to make sure that we go back up and we look at our denominators and see what they used to be. And see if any of our answers, when plugged in, will make them 0. So if I go ahead and take my negative 5 back up here, that would be negative 5 minus 5, which is negative 10. So that's fine. If I put my negative 5 here and add 3, I would get negative 2, and the same thing with the last one. So this p equals negative 5 can stay. We checked them. What about negative 1? All right. If I put negative 1 in here, minus 5, that'd be negative 6, which is not 0, so it can stay. If I put negative 1 in here, that add 3, that's positive 2, so it can stay, and then it'll be the same with the last one. And so we have 2 answers that would work in this fractional equation. And so we keep both. Okay, we got 2 more to go. All right, let's take a look at this fractional equation, and we got a bunch of stuff. We got 2 6s and an x plus 3. So let's think about what our LCD could be. It's definitely going to have to be an x plus 3. No getting around that. And we're going to have to pick the 6. Okay, so we're going to have the 6 and the x plus 3. So this one right here is going to need the 6, top and bottom. This one is going to need a 3 to turn it into 6, top and bottom. But it is also going to need the x plus 3. Okay, this one has the 6, but this one's going to need the x plus 3. And this one's going to need the 3 to turn it into 6, but then it also needs the x plus 3. Whew, okay, here we go. There's 6 and x plus 3. That makes 6 and x plus 3. That's 6 and x plus 3. That's 6, and that's x plus 3. So now all we have to do is take our numerators and very carefully figure out what do we have here. So the very first fraction would be 6 times negative 3, which is negative 18. Then we have a plus sign. 1 times 3 is just 3, but this is also here. So we're going to distribute, and we get 3x plus 9. Okay. Then we have our equal sign. And then we have x times x, which is x squared, and x times 3, which is 3x. Then we have that minus sign. And again, we don't like to get tricked by it. So we're going to turn them into a positive, and we're going to make this into a negative. And then we're going to say negative 1 times 3 is just negative 3. And we're going to distribute that and get negative 3x. And negative 3 times 3 is negative 9. All right, so now we just have to clean this up. So I'm going to go ahead and say I got a square term on here on the right-hand side, and it's positive, so we're going to bring these terms over. So I'm going to go ahead and add 18. That's gone. I'm going to subtract 3x. That's gone, and then I'm going to subtract 9. And then that'll be gone. Okay, so what do we have left? We have an x squared. We have positive 3x and negative 3x. Those are opposites. They will cancel each other out, but we still have this other negative 3x, so we'll put him down. We have a negative 9 minus 9, which is negative 18, and then negative 18 plus 18 would actually give us 0. So there's nothing else left, and so we are now equal to 0. So it's not a trinomial. However, remember the first type of factoring you're supposed to check for, which is greatest common factor. There's an x in common, so pull it out. Left over would be an x minus 3. And we can't factor anymore. However, we do have two factors, and we set the x, who was the greatest common factor, equal to 0. And we set the x minus 3 equal to 0. Go ahead and add 3. And x comes out to equal 3. And there's our two answers. However, we cannot accept both of them unless we check with the original denominators to make sure that none of our answers turn those denominators into 0, making the fractions undefined. So if we take our first answer of 0 and we put a 0 in here, 0 plus 3 is 3, and none of the other fractions have x's in their denominator, so we don't have to check in any of them. So we can keep the 0 because it doesn't make that first fraction undefined. And now we're going to go ahead and test our other answer, which is 3. And if I put a 3 in for this x, 3 plus 3 is 6. And that's also not 0. So we could go ahead and keep both of our answers in this one. Okay, one last question. All right, so when I look at number 6, I automatically look at the denominator of the very last fraction and realize he's a trinomial. So I'm going to go ahead and do my x box. I'm going to see what it's made out of. Multiply to negative 6 and add to 1. Numbers have to be nice and close together, which is 3 and 2. And to get a positive 1, 2 has to be negative, which helps my multiply to negative 6. Because he's a nice, easy trinomial, we'll throw those factors into x plus 3. And x minus 2. And I'm going ahead cross this out because it's been replaced with its equivalent form. And so now looking at the first fraction, it has the x minus 2, but he's lacking the x plus 3. Okay, the middle fraction has the x plus 3, but it doesn't have the x minus 2. And now if we go ahead and look, x minus 2, x plus 3, x minus 2, x plus 3, x minus 2, x plus 3. And so now we can go ahead and grab those numerators and worry about the equation that we're going to get from them. Okay, so we have, looks like an x times an x, which is x squared, x times 3, which is plus 3x. Careful, you get a minus sign next. So remember what we do with it. We make it a positive and we put the negative closer to the 8 so that we're actually distributing a negative 8. And so that'll be a negative 8x plus 16. Equal sign and 10. All right. I see the square term. It's positive, so it can stay there. I'm going to go ahead and bring my 10 over. and I will have an x squared. Positive 3x minus 8x is negative 5x. And 16 minus 10 is positive 6. And we're equal to 0. That is a nice easy trinomial. So we can put our x box up again. Multiply is 6. And our add is negative 5. So again, 6 and 1 could work, or 3 and 2 could work. So we got to be very careful when we pick our numbers. But I believe it's going to be 3 and 2, with them both being negative, because that will give you the negative 5 when you add them, and it'll give you a positive 6 when you multiply them. Okay. If you were thinking about 6 and 1, why 6 and 1 won't work, the 6 would have to be negative in order for the add to negative 5 to work. But then when you multiply them, it multiplies to negative 6. And our multiply is positive 6. Okay, so we're going to go ahead and throw them into our factors. So we got x minus 3 and x minus 2 equal to 0. No t-chart. This factor is going to get set equal to 0, and it's going to give me x equals positive 3. This factor is going to get set equal to 0, and add 2, and x comes out to equal positive 2. We have one last thing to do, and we're going to check our denominators. So if I clear them out of here, and I take 3 back, 3 minus 2 is 1, so it can stay. If I go in the middle and replace that x with 3, 3 plus 3 is 6. And if they work in those and this one's made out of it, chances are it's going to work there. But you can check it if you want. 3 squared is 9, plus 3 is 12. 12 minus 6 is 6. And so x equaling 3, he can stay. Okay. Let's take a look at the 2. So again, if I clear off my denominators and check 2, okay, and I replace this x with 2, 2 minus 2, 2 minus 2 is 0. Therefore, this answer is not going to make sense to the first fraction, because when I plug it in, it's going to be 2 on top divided by 0 on the bottom, and you're not going to be able to subtract that from the next fraction. And so this is going to have to get rejected. Okay? It makes your fraction undefined. Makes fraction undefined. Sometimes I like to write a reason about why I'm rejecting. Okay, and so we'll keep x equals 3 as our only answer. All right, hopefully that helps. All right, guys, I'll see you on the next day.